we are going to look at graphing logs. So now that you've graphed exponentials, now we're going to look at graphing logs. So remember that if f of x equals a to the x, so if we have an exponential function, the inverse of that exponential function is a log, or a logarithm, however you want to say it. So therefore, the inverse of this is log base a of x. So I wrote it down here as well. So this is log. Now be really careful with how you write it. A is that base of x. It really doesn't matter what letters we use, but what you'll see is the base of your exponential is the base of your logarithm as well. So, and we can do it by solving it, and we're going to look at inverses of logs and inverses of exponentials and being able to rewrite them. But our focus right now is just going to be to graph these. And we're going to graph the parent function for log base 10. And then we're also going to look at the transformations. So as I said, we're going to look at log of any base, but we're just going to use 10 just for clarity, because our calculator can do base 10. So I can type into my calculator the log of 1, the log of 2, the log of 3, the log of 4, etc. And I can figure out what do I get. Now when you do that, you could also rewrite this exponentially if you remember exponential form. But since you know an exponential is, so the inverse of this is 10 to the x. So if I were going to graph 10 to the x, so I put 0 in, I get 1. I put 1 in, I get 10. I put in -1, I get 1/10. So that's my parent function for a log. But I'm doing the inverse. And what we know when we do the inverse is we interchange our x and y. So therefore, this value that was at 0, 1 is now at 1, 0. This value that was at 1, 10 is now at 10, 1. This value that was at -1, 1/10 is now at 1/10, -1. So we have, let's see how well I can draw this. This is hard to draw. Oh, not too bad. Not terrible. That is the graph of a log. That's this. And again, if you use your calculator, you can go ahead and punch that into your calculator and find each of the values along the way as well. Also, what you'll notice is I can't get any negative x's because in my exponential, I have no negative y's. So therefore, keeping in mind what's switching around. So what we have present in every single log function is a vertical asymptote. That vertical asymptote is on my y-axis. So we'll fill that in right away. X equals 0 is your vertical asymptote because it crosses the x-axis. My x-intercept, where does it cross my x-axis at? It crosses at 1, 0. Y-intercept, none. Domain goes from here over, so therefore it excludes 0 and goes to infinity. And your range keeps going up and down forever. Therefore, your range is y is an element of the reals. And now I did this with base 10 just so that we could figure this out and graph it without using our calculator. I could have done it with base 2, but all of these, no matter what, will have the exact same x-intercept, no y-intercept, same domain, same range, and asymptote until we do transformation. So now we are going to graph that parent function with some transformations. And I know I did the example with base 10, but again, think about what you automatically know. You know every single log has a vertical asymptote. You know every single log has a x-intercept of 1, 0 because the y-intercept is 0, 1 in all exponentials. So you know there's two important characteristics for every single log function, that vertical asymptote and that intercept. So using that information, now we're going to do transformations. So since we have this number that's attached to x, so we know that is a horizontal shift of 2 units to the right, because it's the opposite of how it affects your x. And then here, there is a vertical shift because that's not attached to the x, that's your y value, and that's always the same operation of 1 up. So what I'm going to do is I'm going to tentatively draw my parent function in. So we know we automatically have that vertical asymptote. And then we also have that x-intercept of 1, 0. And then it kind of does this situation. Okay. And then I know I have this point over here at 10, 1. So that's always going to be based upon your base. So therefore, I also have this value over here at 10, 1. Again, because its base is 10. If its base was 2, it'd be 2, 1. If my base was 5, it'd be 5, 1. So now what I'm going to look at is all my transformations. So since I'm shifting everything 2 units right, so this whole graph is going to shift 2 units right. Does a vertical asymptote move when I move it to the right? Absolutely. What about if I move up and down? Would my asymptote move anywhere if I move up and down? No, it's the opposite of exponentials. So therefore, all of these points are going to shift 2 units to the right, as is my asymptote. So we're going to move these points. Okay, forgive me for right now, because I know we shouldn't extend our graph, but we're going to just for the time being to make it a little bit easier on ourselves. So 1, 2, and then my asymptote shifts over 2 as well. Move that point a little more. Okay, so now what I do know is I have my vertical asymptote at x equals 2. But now I haven't shifted anything up or down yet. All I did was shift the right. So now everything's going to shift up 1 unit as well. Again, the asymptote is not going to be affected by that. But this point is going to shift 1 unit up. I'm going to give it a new point. So this point goes here, and this point goes here. So this point here is at 12, 2 right now. And then I draw my curve the best of my ability. Sorry. That should be more of a curve, not a straight line. And that is your transformation form. So that's right here. We graph that without our calculator. So my domain now, my x's go from my asymptote to the right. So it starts at -2, excluding -2, and it goes to infinity. And then my range is y is an element of the reals. It's all real numbers for my range. Or you can go -infinity to infinity. So with your transformations, think about those points. Think about what's happening to each of those points. And then shifts left, right, up, down. And we could vertically stretch them as well. Okay, so logs. Logs are the inverse of an exponential. Just like an exponential is the inverse of a log is the inverse of an exponential. Therefore, my x's and y's switch. So domain and range switch, asymptote switch, all that stuff. Parent function, whatever your base is, you can always make a table if you need to. Think about what the exponential is, if that helps you, and then interchange those x's and y's. Or think about, okay, these key points. I've got 2 key points and an asymptote, and then I'll move those as well, whichever way you want to do it. I'll go through one in class that has lots of different transformations to kind of give you a good encompassing feeling of, yes, I can do these. Okay, great job graphing logs.